Hello everyone, we're Team 12, Crosswatch Incorporation. Our Capstone project is a four-way stop sign intersection management system, Watchbox. Here is a front view and rear view of the Watchbox. So this is an overview of the Watchbox. We have a large enclosure, a smaller enclosure, and an extension arm that connects the two together. On the front of the large enclosure, there is a RGB LED panel that is responsible for signaling vehicles, and a hole where the Pi camera pokes out to detect pedestrians and their direction. Inside the main enclosure, there are several components: the Raspberry Pi 4 main control unit, the cooling fan to prevent the Pi from overheating, the LED control circuit, the 3 MOSFETs here, the Pi camera, as we discussed, for pedestrian detection, the buzzer for speeding vehicles, the USB accelerator for real-time processing of the vehicle turn signal, and ESP8266 for mesh network to communicate with the other watch boxes. On the near here of the watch box, there are 2 waterproof cable glands where the wire come out. On the bottom side of the watch box, there's 2 brass clamps here and here that locks the main enclosure, the extension arm, along with the smaller enclosure to the existing stop sign to prevent it from falling off. And here, in the small enclosure, there's only 2 components: the LiDAR sensor that can detect the vehicle and its speed to determine if it's speeding or not, and the USB camera that captures vehicle and send the information to the Raspberry Pi for vehicle's turn signal processing. One of the most important features of the Watchbox is vehicle turn signal detection. Here we can see that an oncoming vehicle is captured by the USB camera, and the right turn signal is captured. When the Raspberry Pi sees a certain amount of right turn counts, the case will be treated as right turn. The same goes for left and straight. This is used to improve result accuracy. In this case, the left turn signal is captured instead. Lastly, the case of the vehicle going straight. Once the Raspberry Pi determines a turn signal, it will send the information to ESP8266 when the bounding box reaches the bottom of the screen as shown here. The intersection chosen by Crosswatch for demonstration is Irving Street and Denby Avenue. The northwest corner is corner 1 and the southeast corner is corner 3. For pedestrian detection, if a pedestrian crosses in front of a vehicle at the testing corner, they will be treated as going in the X direction. Otherwise, if a pedestrian travels in parallel with the vehicle in the testing corner, they will be treated as going in the Y direction. The LiDAR module is used to determine oncoming vehicle distance and speed. If a vehicle travels too fast, then an alarm will be triggered to warn nearby road users. In the simplest case, with a single vehicle and no pedestrians, the vehicle can proceed right away upon stopping at the stop line, as shown here. Now, with an introduction of a pedestrian, the vehicle can still proceed right away if the pedestrian does not impede the vehicle's path. Here we can see a pedestrian traveling straight and a vehicle turning left. There are no interference, hence the vehicle can go right away. Now that if the pedestrian travels in the path of the vehicle, then the vehicle will have to stop at the stop line and wait until the pedestrian has fully crossed the intersection. Then the vehicle can proceed. In this case, the pedestrian crosses right in front of the vehicle, hence the vehicle will have to wait until the light turns green. For the case of 2 vehicles and no pedestrians, the vehicle that arrives first will have the right to proceed. In this case, the white car arrives at the intersection first, hence he gets to go first. The red car will have to wait, and then he can proceed. Now for the scenario involving 2 vehicles and 1 pedestrian. If the pedestrian blocks 1 or more vehicle, then they will have to wait. After the pedestrian leaves, the 2 vehicles can proceed in the order determined by a Watchbox. In this case, both vehicles are going straight, hence they can go at the same time. Similarly, for the case of 2 vehicles and 1 pedestrian, If the pedestrian only blocks one vehicle but not the other, then the vehicle that's not blocked may proceed first. The blocked vehicle may proceed after the pedestrian leaves. In this case, the white vehicle is not blocked and the red vehicle is. Lastly, in this case of two vehicles and two pedestrians, both pedestrians are impeding the white vehicle, hence the red vehicle that comes can proceed right away, and the white vehicle will have to wait until both pedestrian crosses. Although the white vehicle came to the stop line first, the red vehicle may proceed first due to the involvement of pedestrians. And here is a casual drive-by of a random taxi. More cases may be presented during the final demo presentation. Thanks for watching.